Okay, so last time we went through 2-1, 2-2, and we did a few questions out of 2.3. So what questions do we have out of 2-1? Do we need to look at any of those? Sure, we can look at question number 6 here. Okay, what other ones? Is there going to be a hit on that one? Let's lock my calculator back in my office too. Are there any others to look at? Just question 6. Okay, what about 2.2? Circles. Do we need to look at any of those? Sure, yep, we can actually look at both those if we need to. We got plenty of time. And is that it? Anyone else? Got any others? Okay, what about the couple of questions we did out of 2.3? Do we need to look at any of those? And I think we just did, if I remember right, question 1. We looked at 4, 5. I think that was about it. So any of those we need to look at. Those are pretty simple. Okay, so we'll look at these. And then we will finish up 2.3. Okay, so let's go ahead and get started with 2.1, question number 6. And these are just general graphing of lines and plotting points in 2.1. So we're going to look at question 6 and we're going to find the distance. So if we remember our distance formula D is the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Now, when we work with these roots and when we square, a square root is going to go away. So those square roots can be combined together, and when you square that square root, it goes away. And we've got these points to use with this formula. So we've got 5 squared of 7, comma, minus 3 squared of 11. That's our first point. Our second point, Q, is 9 squared of 7, comma, minus 2 square root of 11. And we're going to label these ordered pairs x1, y1, x2, and y2. And then we'll plug those in to our distance formula here. So let's plug those in. And we've got 5 square root of 7 minus 9 square root of 7 quantity squared plus we have a minus 3 square root of 11 minus a minus 2 square root of 11 quantity squared there. Is everyone all right with how I just plugged the numbers in? Now, what can we do with these roots? Well, these roots can be combined together in each set of parentheses. And we need to also be very careful with that double negative, because the double negative here, again, is going to make that positive. So what do we have? Well, think about this as 5x minus 9x, because that's pretty close to what it is. So 5x minus 9x would make it minus 4x, right? But in this case, we don't have an x, we have that square root of 7. So that's going to be minus 4 square root of 7 quantity squared. And then what about the other one? Well, minus 3x plus 2x would make it a minus x. In this case, we have those square roots. So that would simply be the minus square root of 11 quantity squared, right? Okay. So what are we going to do next? Well, next we're going to go ahead and square. And what happens when we square that negative 4? Well, that negative 4 becomes a positive 16. And when we square that square root of 7, it just becomes a 7. And then we've got the square root of 11 squared, so that's just going to be a positive 11. Now we can break that up. Let me find my calculator. I think I may have left it back in the office. I'll be right back. Okay, so we were back here. So what we're going to do, we're going to take that 16 times the 7. That's 112 plus 11. That gives us then 12 plus 11. That gives you the square root of 123. I don't think that'll, well, that 123 won't break down because the only thing that we can use is a 3 and a 41. And 41 won't go any further. So that's all you can do on that one. And that would be your final answer, which is the square root of 123. Do you see how I did that? So I combined those roots together in each one. When I squared, the number out in front gets squared. The square root goes away. It just looks more intimidating than the others because of those square roots. But other than that, it's no different. Okay, question 3 out of 2.2. So this one is trying to find whether or not this is a circle. And if it is a circle, we'll go ahead and find the center and the radius. So we have x squared plus y squared minus 12x plus 4y. And I'm going to go ahead and move that 31 over, just to save me writing an extra step. Because when we look at this, what do we want? Okay, we want to make sure that all the x and the y's are on the left-hand side. Numbers go on the right-hand side, which it is. Now we need to complete the square twice. Yeah, it should be. My mistake there. Forgot to change the sign when I moved it over. Sorry about that. Now what we're going to look at is we're going to look at the x part and the y part separately. And when we complete the square, what do? Half and square. That's all you have to remember. Half and square. So for the x part, we've got x squared minus 12x. And half of negative 12 comes out to be a negative 6, doesn't it? Now, whatever we take out, or move down below to factor, we have to add it back in so that it'll work. So 6 squared is a 36. So that 36, we've got to make sure we remember where it's at, because that's going to be added on at the end. Okay. What about the y part? Well, the y part is done in a very similar manner. We've got y squared plus 4y, and half of 4 is a 2. And then what do we do with that 2? We square it, and 2 squared then is a 4. Now we can rewrite it, and we can see what we have left here. So we've got x minus 6 quantity squared plus y plus 2 quantity squared. That equals a minus 31 plus 36 plus 4. So that reduces down to be then a 9 on the right-hand side. And we've got an x minus 6 quantity squared plus a y plus 2 quantity squared. Okay, so we got to this part. And when we look at it, is this a circle, yes or no? How do we know that it's a circle? Well, when we look for it to be a circle, we look at the right-hand side. Once it's all done, we've broken everything down. If that right-hand side is positive, then it is a circle. If it is negative, it is non-existent. If it's 0, then what is it? If it's 0, it's just a point. So ours is a 9. So this is a circle, and let's go ahead and get the center and the radius. So this is a circle. Now, what do we do for the center? Whenever we go back and forth between the center radius form of this circle and the center, what do we do with our signs? Does anyone remember? We have to flip it, right? So that becomes a positive 6 and a negative 2. And my radius is not 9. It is the what? Okay, it's not 9. My radius would be what? Yep, square root of 9, which is then what? 3. Yep. Remember, because this right here is r squared. So we want to get our radius, and how do we get that? We just take the square root. So our center would be at 6, negative 2, and our radius would be a 3. And this is a circle. And again, why is it a circle? Well, it's a circle because that 9 is a positive number. Question 4, we're going to have to divide out first. So let's rewrite question 4, and I'm going to move that 12 over. So we've got for question 4, 2x squared plus 2y squared minus 4x plus 12y. And we're going to move that negative 12 over, so it becomes a positive 12 there. So all I did was just move that 12 over. Now this one is a little bit different because when we use completing the square and to get it in center radius form, we can't have any number in front of the x squared or the y squared. And so we have no choice but to divide everything by 2. Why? Because there's a 2x squared and there's a 2y squared. And those numbers will be the same. If they are not, then it's an ellipse, not a circle. And we really don't discuss ellipses at all in this class. So we're going to go ahead and divide everything by 2. That's going to get rid of the 2 that's in front of the x squared and the 2 that's in front of the y squared. Now we are left with something that we can work with. So now we're left with x squared plus y squared minus 2x plus 6y, and 12 divided by 2 is that 6th. So that's where we're at so far. Now we're going to repeat the process and work it out the exact same way that we did the previous one. We'll look at the x part first again. And on the x part, we've got x squared minus 2x. So we half and square. So half of a negative 2, use the right variable here, it should be x here. Half of that negative 2 is a negative 1, and negative 1 squared is positive 1. So we need to keep track of that 1, because that 1 is going to have to be added back in. Next one, we look at the y part. What do we have for the y part? Well, we've got y squared plus 6y, half and squared. So half of that 6 is a 3, and 3 squared is 9. And we need to make sure that we keep track of that 9. Okay, and we're almost done now. So let's rewrite and see where we're at. So rewriting, we now have x minus 1 quantity squared, y plus 3 quantity squared, and that's going to then equal 6 plus 1 plus 9. And that breaks down to be 16. And so now here's the question that we need to answer. Is this a circle? Yes or no? Yeah. Why do we know it's a circle? Because that 16 is positive, right? If that 16 would have been negative, would it be a circle? No. So this is a circle. And the center would be what? Changing the signs, switching them around. The center would be 1 comma negative 3. And my radius is not 16. It's the square root of that 16, which is then what? 4. So that is a circle, and it has a center at 1 negative 3 and a radius of 4 there. Everyone okay with that? Now, on circles, what do we need to remember? Well, we need to remember when we complete that square, what do we do? Half and square, right? Now, when we go to the center, from the center radius form, what do we do with our signs? Switch them, right? They invert. What about your radius? It's not the number on the end, it's the square root of it. So my radius is not 16, it is what? The square root of 16. So you've got to make sure that you remember those 3 facts there. Are there any other questions out of 2.2 before we move on and finish up 2.3? Anything else? Okay, well, if not, then we're going to go ahead now and work on 2.3. And we talked a lot about 2.3 last time, but what we didn't really cover was the equations. And what makes an equation a function? So an equation is a function if it can be solved for y. So if you can solve an equation for y, then it's a function. And these are not functions, by the way. Not functions are y squared, y to the 4th, y to the 6th, all the rest of those, and also inequalities. They are not functions either because they break the vertical line test. And we talked about that last time. The vertical lines, we drew those vertical lines, and we used that to figure out if it was a function or not. And so an equation is a function if it can be solved for y. So we're going to look at some of these now, and we're going to see if these are functions or not. And then we'll also find the domain and the range. And we're going to look at functions first. And once we've talked about the functions, then we'll look at things that are not functions, and we'll find the domain and ranges of those. So the domain, and this is for functions here, the domain is negative to positive infinity unless x is in the denominator of a fraction, or the problem has square roots, or the function has square roots. And in previous courses, you only really looked at the domain. Now the range is a little bit different. And these again are just for functions. Now the range is going to be your y values. And for the range, what you do is you solve for y. And once you've solved it for y, then you check values. And then you check x equals 10. And you also check x equals a negative 10. And you see what those values are. And if both are positive, then what you have is 0 to infinity. If both are negative, then you have negative infinity to 0. And if one of them is positive, one of them is negative, then your range is negative to positive infinity. So these are pretty simple, and unless it's a fraction. If it's a fraction, it's a little bit different, which we only have a couple of those. Okay, let's go ahead now and look at a couple of these. We're going to determine if these are functions or not. And then we'll also find the domain and the range. And the first couple are going to be functions. So here's one we're going to look at. How about y equals 5x minus 8? Okay, is this a function? Well, obviously it is. Now, how do I know it's a function? It can be solved, or it is already solved for y. So it's y equals, so it has been solved for y. So now we know that this is a function. What about the domain? Do we have any square roots at all? No. Do we have x in the denominator of a fraction? No. So no fractions with x in the denominator, no square roots, so my domain would be negative to positive infinity, right? What about the range? Well, for the range, we check values. And for our range, we're going to check values. We're going to check x equals 10 first. And so we're going to plug that 10 into our equation, which is y equals 5x minus 8. So we're going to plug in that 10. And we'll work that out. That's going to be 50 minus 8, which is a 42. And that's positive. So that one's positive. What about a negative 10? If I plug in a negative 10, what's going to happen here? Well, if I plug in a negative 10, and I get 5 times negative 10 minus 8, and that makes it a minus 58. So what kind of values do we get out of here? Well, we can get positive values out, right? And we can also get negative values out. So we can get both positive and negative numbers. That means my range is negative to positive infinity. So yes, it is a function. My domain is negative to positive infinity. And my range is negative to positive infinity as well. Okay. Let's try a couple more of these. Not very many, just a few. Let's look at this one now. How about y equals 9x to the fourth power? So is this a function? Yes, it is. Why is it a function? Because it's y equals. So that's the easy part. It's not very difficult at all to determine if it's a function. Now, once we know it's a function, then we look at our domain. Do we have any square roots? No. Do we have any fractions at all? No. So what's our domain then? Negative to positive infinity, right? And for our range, we again check values, and we check x equals 10 and x equals a negative 10. And look what happens here. If I plug in that 10, well, that's 9 times 10 to the fourth power. And 10 to the fourth power should be 10,000 times 9. That makes it 90,000. And that's positive. If I plug in a negative 10, well, when I take a negative number to the fourth power, it's taking it 4 times. It's an even number, so that's going to make it also positive, and it's 90,000 as well. So what kind of numbers do I get out? Did we get any negative numbers here at all? No, they are only positive, and the smallest number I can ever get out is 0. So since these are both positive, the range is 0 to infinity. So there's your range there, 0 to infinity. Now, what about a fraction? Well, let's try one of these. Y equals 8 over x minus 9. This is a very simple one. You'll see questions like these in your homework. Okay, first off, is it a function? Yes, it's already a function. How do I know it's a function? It's a function because it's been solved for what? Been solved for y. So this is a function. What about the domain? And we talked about this way back in 1.5. Now, what can we not have in the denominator of a fraction? Does anyone remember? We can't have negative numbers, or not negative 0, right? Because you cannot have division by what? 0. Okay, we've done these before. So what number is not in the domain? Does anyone know what would not be in that domain? It's not 0, but what number is not in there? 9. And how do we write it now? Well, our domain is going to be negative infinity to 9 union 9 to infinity. That is saying that every number works except for 9, because 9 will give you division by 0. We're not going to have to check numbers for the range, because for the range, all these rational functions have the same range. So all rational functions have negative infinity to 0, union 0 to infinity for the range. So all rational functions have that for your range. And the domain is found by simply determining what number gives you division by 0. So it is a function. You find out what number doesn't work, that's your domain. And the range for all these rational functions is negative infinity to 0, union 0 to infinity. We'll do one square root problem, and then we'll look at something that's not a function. So this one has a square root in it. And again, just like the others we've done so far, this one is a function. So we know it is a function. What about the domain? Well, for the domain, since we have a square root, what we're going to have to do is set that root greater than or equal to 0. So since we have a square root, we take what is under this root and we set that greater than or equal to 0. And I didn't give you very many of these questions at all. Most of them just ask if it's a function or not. So that's why we're not going into a lot of detail. If you take a calculus course, you're going to spend a lot of time talking about functions. But in this class, we're barely touching the surface. So we take what's underneath this root, which is 2x plus 5, and we're going to set that greater than or equal to 0. And then we can solve it by moving that 5 over and then dividing by the 2. And so now we've got x is greater than or equal to a negative 5 halves. And in interval notation, it's opening towards the x, so that would be negative 5 halves with a square bracket to infinity for your domain. So you just take what's underneath that root, you set it greater than or equal to 0, and then you simply solve it. And again, we're just barely covering these. If you take a calculus course, you will spend a lot of time talking about functions and looking at domain and ranges. What about the range now? We're going to plug in values. So let's plug in a 10. That's going to be the square root of 2 times 10 plus 5, which is the square root of 25, which is then 5. So that piece is positive. I'm sorry about that. So we plugged in that 10 back in our original. Okay, and then we just evaluated it down because there's our original. Clear up here. So that's our original. We plugged in our 10 and we got it to be positive. Now, if we try to plug in a negative 10, it's not going to work at all. Because if I try to plug in a negative 10, then what I get is I get the square root of 2 times a negative 10 plus 5. That's the square root of 15. That's negative. And if you remember back from 1, 3, that would come out as I squared of 15, right? And can we ever graph an imaginary number? When we go to graph things, what do we have? We have x's and y's, right? And it's only real numbers. So can we graph this I squared of 15? No. Okay, so in this case, we only get out positive values. So we only get out positive values. So that means then that my range would be 0 to infinity. And that's going to be your range then. Now we're going to quickly look at things that are not functions. And we're only going to do one of these because I only gave you one of them in your homework. These are not functions. So if it's not a function, for the domain, what you need to do is solve for x, and then you've got to check y equals 10 and y equals a negative 10, just like we did with the range earlier. So we just plug those two values in and we see what the signs are. The range for these is like the domain, and the range is negative to positive infinity. Now, if you do take a calculus course, you'll get into functions and things that are relations. It's called a relation when it's not a function, that are a lot more complicated. But I'm only giving you very simplified ones. So the ones I'm going to give you when they're not a function, they're a relation, and their range is always negative to positive infinity. So let's look at just one of these, and let's see why this one is not a function. And this is very, very similar to question 5 in your homework. Just different numbers is all. So x equals y squared. Well, why is it not a function? Okay, it's not a function because of that square. So anytime you have a power on that y, it's not going to be a function. Also, inequalities are not. We really don't discuss those much at all. Y squared, y to the 4th, y to the 6th, y to the 8th, y to the 10th. Those are all going to be not functions. So if it's not a function, it's called a relation. And what about our domain? Well, we find the domain just like we found the range in the previous question. And what we do is we just plug our values in. So we're going to check y equals 10. And if I plug in y equals 10, and that gives you x equals 10 squared, which is 100, and so that's positive. If we plug in a negative 10, then that gives you x equals negative 10 squared, which is also a positive 100. So we got out positive values, and we got out we only got out positive values, no negative values at all, so only positive. So if they're only positive, then what would my domain be? Well, my domain would be similar to the range, 0 to infinity. And this is not a function. So what's my range? Well, it's not a function. And so all of these have a range that is negative to positive infinity. And again, I only gave you one of these in your homework, and that's question 5. We have one more real quick topic. I think we may have covered it last time, but we'll go over it again. we're going to take an equation and we're going to rewrite it using function notation. So what the directions are going to be is we're going to take this equation and we're going to solve for y and replace y with f of x. And we're still in 2.3. We'll take a break right after this question here. So this is like question 3 in your homework. Question 3 says an equation that defines y as a function of x is given. You want to solve for y in terms of x and replace y with your function notation f of x. So we've got a function here. We want to solve it for y. So move that 4x over. And this is a very easy question. And we want to get rid of that negative. So we divide everything by a -1. Now we've got y equals 4x minus 9. And we replace that y with the function notation f of x. So my final answer would simply be f of x equals 4x minus 9. And that's all you need to do. So that now finishes up section 2.3. We'll take a short break. We'll come back and we'll work on 2.4.